Okay, looking at lesson 4, continuing on with our circles. We're going to talk about inscribed angles and polygons to find arc measures. So an inscribed angle is a little bit different than a central angle. So you'll see like an inscribed angle goes not to the center of the circle, it goes to the edge of the circle and then bounces off it and touches the circle in 3 different places. So we've got point A, point D, and point B. And so like the angle that we're looking at is angle ADB, which again creates this space and corresponds to the arc AB. So how this relationship works is that this angle, this inscribed angle, is half of the arc. So like what I mean is that whatever my arc AB is, the angle ADB is going to be 1/2 of it. So if I said that this arc right here was 80, then this angle would be 40. It has to be half of it, and it works both ways. So for example, if we look at number 1, here's my arc. My arc is HF, and again, my inscribed angle goes from HGF. So I'm going to take 90, and I'm going to multiply it by 1/2 or divide it by 2, whatever, and get this angle equal to 45 degrees. So my angle, the measure of angle HGF equals 45 degrees. Over here, so I'm working the opposite direction. This time I have my inscribed angle being 38. So to get my arc length, so again, I'm going to take whatever my angle was, and I'm going to multiply it by 2 to get my new minor arc. 2 times 38 equals 76 degrees. And then if we look at this one, okay, so I'm going to look at their endpoints. And I'm going to say that, okay, this angle right here from Y to Z and Y to W, it has endpoints right here. And when I go to highlight my red section, I see that, hey, I actually have the same endpoints. So because my inscribed angle is going to have the same endpoints, it actually is going to create the exact same arc. So these two things are going to be equal to each other. So if this is 72, this is 72, which again means I got to take my angle, I got to multiply it by 2, and I'm going to get 144 degrees for my arc. The measure of, let's see here, arc ZW equals 144. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. And again, this means add up to 180. So I've got my quadrilateral in here, and if all of the angles add up to 100, or if the opposite angles add up to 180, then I have a legit circle and a quadrilateral inside of it. So basically, I'm looking for E and G to be 180, and I'm looking for F and D to equal 180. So I can use that, and I can set up basically 2 different equations here. So I'm going to say, all right, first off, I'm going to do X and 82. So again, because they share the endpoints, that's kind of why they are related, or why we can do this. So we're going to say X plus 82 equals 180. I'm going to subtract it and get X is equal to, what would that be, 98, I want to say. And then for Y, I'm going to say, all right, these two angles are going to add up to equal 180. y plus 68 equals 180. Subtracting, and oops, my brain isn't working right now. Y equals 112 degrees. Similar idea, slightly different, a little bit more algebra, but still opposite angles are going to add up to 180. 10x plus 8x equals 180. 18x equals 180. Divide by 18 and you get x equal to 10. These two angles adding up to 180. 2c minus 6, not going to matter with the parentheses. 2c plus c is 3c minus 6. Add 6 on both sides. 3c equals 186. And 186 divided by 3 equals 62.